Hello again, my lovely, lovely students. So, this is going to be a short little section on matrices, or you would just call them a matrix, all right, if you were just talking about one single matrix. All right, we're going to talk about what a matrix is, we're going to talk about what they do, and we're going to talk about how to describe like the size of a matrix, all right, and what position something is in a matrix. So what a matrix is a rectangular array of numbers. Okay, and I've got three matrices here for you. They're not that interesting to look at, but they are interesting. Okay, the thing I want you to know and keep in the back of your mind is that matrices do something. All right, they represent stuff. They might represent how to rotate something in three-dimensional space, or how to translate something in three-dimensional space. All right. So they represent. They can represent time. Each entry here might represent, a week, a day, and a minute. So it could represent time. Each number in this right-hand matrix here could represent something's location. I don't know like how to explain it exactly, but you could have the three-dimensional coordinates on the globe, or in space, in outer space, for that matter. All right, so this could represent where something is located in space and where something is located in time. Probably going a little deep there because I don't know what I'm talking about. Anyway, too much Star Trek, I guess. One thing that they are used for is color changes. All right, let's say this first matrix here, I have no idea what these numbers could actually be. Let's call it, so each of these cells might represent, how much of a color that you would add to make a certain color. So one might be blue, two might be yellow. So you're doing 1 part yellow, 1 part blue, 2 parts yellow, 5 parts red, or something like that. But this would represent like the original color of something. And this second matrix over here might represent how you want to change the original color. All right. And so what you would do is you would multiply those two matrices, and that would give you a data representation or a numerical representation of those colors and of the new color. So let's say you were trying to turn up the brightness. I don't know. Like I said, I'm not really into graphic design or anything, but it might be 1, 1, 1, 1. And this might scale up the brightness or the contrast, by a factor of, I don't know, 10%. I'm just making up numbers here. But you can take this original matrix, which represents some color, and you can do something to it with this second matrix. Okay. Unfortunately, we're not going to be able to get into all the neat stuff that matrices can do, because it gets deep, it gets difficult. All right, we're just learning we're learning about matrices right now. We're not learning how to apply them right now, because applied math is usually, it comes later. It's a lot more difficult. But anytime that you get into physics or vectors, a lot of times matrices will come into play there. All right, the last thing I want to look at here is the size of a matrix, and to describe a certain position in a matrix. So this first matrix, if you were describing this first matrix here, you might say, oh, it's a matrix that has 6 cells. All right. If you were describing the second matrix, you might say, oh, it has 5 cells. And those would be true things. It has 5 data points, or it has 6 data points. But the convention for how they describe these is they count the number of rows. So we'd say, so the ones that go horizontal are the rows. So this one has 2 rows, and they count the number of columns. So this one, matrix, let's call it matrix A. Matrix A is a 2 by 3 matrix. That's the order of the matrix, or the size of the matrix. You might call it the dimensions. So order, size, dimension, it's all ways of describing how big the matrix is, or the size of it. So the 2 represents the number of rows, and the 3 represented the number of columns. The second matrix over here, all right, notice there's only 1 row. So this one is a 1 by 5 matrix. We'll call that one matrix B. And this last one here we'll call matrix C. And this one is a 2 by 2 matrix. Another thing to point out about this one is that it is a square matrix. It just means that they have the same number twice here. Those are called square matrices. Lastly here is how you can identify certain numbers or certain elements, positions within a matrix. So, for instance here, let's say I wanted to describe that number there, that 5. Well, the first thing I would do is I would put the matrix that I'm talking about. And then in a subscript here, right here, I'm going to put the row and column position that it's in. So it is in the first row, and it is in the third column. So it would be A, and then I guess subscript 13 or 1, 3. And I'm pretty sure I think they use lowercase, if I'm not mistaken. I probably should have looked that up first. But I think it should actually be A, and then 1, 3 is the number 5. If I had said A and then 2, 2, so that would be the second row, and the second column. So that would be number 1. That would be the number 1. If I was looking at matrix B, well, there's only 1 row, so it has to start with a 1, and whatever number you put next is going to represent the column position. So if I said B and then 1, 5, that would be the -2 there, because that's the 5th position over. Okay? So let's say you were trying to describe the 6. How would you describe where that 6 was for matrix C? Well, it's in the second row, and it's in the first column. So it'd be C, 21. All right, and that would equal 6. So I think that does it. So you need to be able to describe the dimensions of a matrix and identify certain positions in a matrix. Okay? I'm not sure. I think it is the lowercase. I shouldn't have even mentioned the uppercase. I think uppercase represents an entire matrix, where lowercase just represents certain elements.